What's going on, guys? So, this is the second job that we'll cover today. We're going to cover T8. So T8 again. You don't have to have them all done in one day, but I'm covering T7, T8, and T9 so that you guys have time to get caught up on anything that has to be submitted this week, and so that at the end of this week and next week, you guys are prepping these jobs to be ready for shop class to go to work. So T8, we're going to be talking about a delta-to-delta transformer bank. Very, very common distribution bank. There's actually two parts to this. Part one, we're going to operate this bank in an open delta, and then in the second part, we're going to put a third transformer in to complete the complete delta to delta. So the first part is an open delta. An open delta system is a system that only uses two 1-to-1 ratio transformers, but has the ability to produce three-phase power. So you're asking two transformers to perform the work of three, so we are going to have to derate that transformer bank. I'm going to cover the jobs first. I'm going to cover part one and part two first, and then I'm going to erase the board and I'll show you guys the calculations up on here. I just have limited real estate to save time. Instead of redrawing all this, I'll cover part one, then part two, then I will cover how we're going to derate this transformer bank. So you derate with an open delta. So right now, T8, open delta. This job requires two transformers. We're going to have primary supply voltage is 208 three-phase 3-wire, 208 three-phase 3-wire, and our make secondary connections to obtain 208 three-phase 3-wire. So, how we're going to do that first, we're going to come out of line 1, come down, we're going to go to H1. Okay? H1 of transformer 1, this is transformer 2. Then what we're going to do is we're going to connect transformer 1 to transformer 2. So we're going to jump H4 to H1, and we're going to bring this up, this jumper, either off of H4 or off of H1, doesn't matter after the tied common, come up, go to line 2. So now essentially we're bringing line voltage between line 1 and line 2, 208 into this transformer. These transformers are rated 120, 240, 120, 240. The highest voltage we can put in an individual coil is 120 volts. So we're going to put these in series to get 104, 104. All right? Same thing over here, except now we're going to put these in series again, H3 to H2, except we're going to bring this H4 up to line 3. Basically the same connections on the secondary side. We want to get 208 out. Well, if there's 104 here, 104 here. I'm going to induce 104 on this coil, so I'll induce 104 on this coil. X4 is going to make up the first part of part A. Again, we're going to put these in series because we want to get 208 coming out. So if we put these in parallel, we would keep the 104 constant. We don't want to do that. We want to get 208 out, so we put these in series. X2 to X3. Then we're going to jump X1 of transformer 1 to X4 of transformer 2. Off of that common point, come down. That's going to make up my B phase. Now I'm going to come off of X1 of my second transformer. Jump X2 to X3. So now between this point and this point, I have 208 from the 104 to the 104 in these coils. Here's 208. So essentially it's 208 volts between A and B. I measure between here and here. Well, I've got 104 on this coil, 104 here. I'm going to measure 208 between these 2 points. So 208 between B and C. Then if I measure between A and C, I'm also going to measure 208 volts. They consider this an open delta because it's open on the one side. I'm just going to draw the secondary side here. So if we draw transformer 1, we have a coil. Transformer 2. Just due to the limited real estate, I'm not going to draw. I'm just going to pretend that this is transformer 1, this is transformer 2, and I'm going to call this right here, we'll call this X4, or I'm sorry, we'll call this, we'll call this X1, this will be X4, this will be X4, this will be X1. So on transformer 1, X1 is jumped to X4. So here's this jumper, and that makes up my B phase. There's your B phase. X4 of transformer 1 makes up my A phase. And X1 of transformer 2 makes up my C phase. There's your C phase. They call this an open delta because, well, the bottom side of our triangle, or the bottom side of the delta, is open. So, because of this, we're producing three-phase power, A, B, and C, except we're going to have to reduce the kVA capacity of this transformer bank because you're not going to be able to get the full kVA capacity out of this. The numbers, again, we'll cover this. It's either 86.5% of 2 transformers, or it's going to be 57.7% of the original 3. We'll cover it, all right? So, this is part 1 schematic. You can see it matches up here. This is part 1 on Blackboard. I will put this video also on Blackboard. It'll actually be a link to YouTube on Blackboard, but this is part 1 schematic. So now, we finished this part, or at least we finished hooking it up. After you do that, we want you guys to hook this up to an empty terminal bank, and then we're going to go through and measure and record the following secondary voltages with no load connected. So you're going to measure A to B, B to C, C to A, and you're going to write those values down. After you do that, come off of that blank terminal strip and go to the 3-phase motor in your booth. Connect to that and then take 3-phase voltage readings with the motor running and then current readings with the motor running. These are all on the secondary side. So now what they're saying, it's been found that the original open delta bank is no longer sufficient to provide the necessary power. You have been asked to add in a 3rd transformer to the original bank. So we operated on an open delta. We have now gone past our kVA capacity, just like in job 4, in T4, how we had to put the 2nd transformer in parallel with the 1st to increase our kVA capacity. Same concept here. Our business has grown. We need more power. We need a bigger transformer bank. So, primary side of the transformer, still 208 3-phase 3-wire. We want the same voltage out of the secondary. 3-phase 3-wire delta out of the secondary. Rag. So, erase this. So now you're going to grab your 3rd transformer. Here's my 3rd one. It's going to be H1 here, H2, H3, H4. Here's going to be X4, I did that right, X3. This here is going to be X2. This is going to be X1. Again, we're going to put this transformer in series just like we did with the other ones. So you can go H3 to H2, X2 to X3. Now what we're going to do is we're going to jump H4 to H1. And then we're going to bring H4 here up to line 1. I'm going to jump X1 of transformer 2 to X4 of transformer 3, and then what we need to do before we turn power back on connected to the motor, we're going to disconnect the motor, disconnect our loads. We need to take a polarity test before we tie this X1 to this X4. We're closing the delta in now at this point, so we need to make sure that there's not going to be a difference of potential between these 2 points. Take your voltage reading. No trickery with this one like there was with the last job. Measure from X4 to X1. Anything below 5 volts, you're good to go. And then I'm just going to take X1 Oh, I'm sorry. Went to the wrong one. You're going to tie X1 to X4 of transformer 1, which is actually the A phase. I thought it was the C phase. My bad, guys. X1 of transformer 3 gets tied to X4 of transformer 1, which is our A phase. All right? So now I'm going to jump into how you're going to derate this. I'm going to use some standard numbers. We're going to pretend that each transformer is rated for 5 kVA apiece. So, we've got 3 transformers. They're rated 5 kVA each. So, 15 kVA total. It's 15 kVA total. The 3 of them were hooked up. What we just had up here, so this, and I'm sorry guys, I jumped a little bit ahead. After you close in the delta on part 2, then go through with no load connected, primary voltage readings, secondary voltage readings, connect a 3-phase motor, and then take primary current and voltage readings with the motor connected, and the same thing on the secondary. So that connection, here's my cursor. That looked like this. Let's just say that each of these transformers, 1, 2, and 3, they are each rated for 5 kVA each, 15 kVA total. So, what you could do is if you had the original transformer bank, so say 15 kVA, say you want to see what your kVA capacity was going to be if you were to lose one. So you lose a transformer, we're going to operate in an open delta with 2. You could take 15 kVA, because you knew that was the total. Multiply that by 57.7%. That's going to come out to, or 15 times 0.577 equals 8.65, in our case, kVA. So, 57.7%, the original 3 transformers. That's what you're going to use, the 57.7%. You see, this comes out to 8.65. Say you only have the 2 transformers, and you see it's operating as an open delta. You want to know what the kVA capacity is. You take the kVA of the 2 transformers, so if they're each 5 kVA, if we've got 2, so 2 Xformers at 5 kVA, add those up, you're going to get 10. 10 kVA times 86.6% equals, or 10 times 0.866 equals 8.66 kVA. So, you use 86.6% or 86.5%, all depending on what textbook you're reading, when you only have 2 transformers. You use 57.7% if you have the original 3 transformers. You could use either formula, flip-flop them either way. Use 57.7 when you have 3, use 86.6 or 86.5 when you only have 2 transformers. Any questions on this job I'm uncertain of? Right here, these 3 questions, we just answered these questions. All right, what type of transformer bank connection is this used? It's an open delta. In this connection, could each transformer operate at its kVA capacity? No, it cannot, because you're asking 2 transformers to perform the work of 3. The only time they're all going to operate at their full kVA is in part 2 when we have 3 transformers in there. If not, what is the percent of the kVA that you can use? You're going to say 57.7% for 3 transformers or 86.6% for 2 transformers, and list 2 advantages of this. Well, if we went through and you had, say a storm went through, the storm we just had came through, knocked out one of your transformers at your business. You don't need every piece of equipment to run on Saturday, but you'd like some equipment to run on Saturday, and the transformer's not coming in until Monday morning. This happened on a Friday afternoon. Well, what you could do is disconnect that 3rd transformer, and you're back to your open delta with 1, 2, 3 phases to provide 3-phase power to your building at a reduced kVA. And the other one is future expansion. You had a small business, you could operate at an open delta, and then when the business gets bigger, put the 3rd transformer in. So, guys, this is T8, part 1 and 2, open delta. Again, quiz questions based off of this job. You guys have any questions, don't hesitate to email me and ask. Have a good one.